Alright, so let's try one more with the quadratic formula. If you want to try it on your own, go ahead and pause it as I put it up, and then if you try it on your own, you can check your answer with mine when we're done. So I'm going to give you one that has a leading coefficient other than 1. That means the coefficient in front of the biggest x value, which is x squared. Okay? Or in math we would say the term that has the highest degree, which is x squared. Okay, so that means that 2 is our a, positive 7 is our b, and 3 is our c. And it's very important that if there's a negative in front of these, you take the negative with those letters. So let's go ahead and put this into the quadratic formula. So x equals negative 7, so negative b, plus or minus the square root of 7 squared minus 4 times a times c, all divided by 2 times a. So we end up with negative 7 plus or minus the square root of 49 minus 4 times 2 is 8 times 3 is 24 divided by 4. That gives us x equals negative 7 plus or minus the square root of 25, ooh, a perfect square, divided by 4. Around up here. So that's negative 7 plus or minus 5, because that's the square root of 25, divided by 4. So how do we use this? So one of our x values is negative 7 plus 5 divided by 4. The other is negative 7 minus 5 divided by 4. So negative 7 plus 5 is negative 2 over 4. So one of our roots is half. The other one is negative 12 divided by 4, which is negative 3. So we could say that our roots happen at negative half 0, and negative 3, 0. This is where our parabola would cross the x-axis. And I should also mention, because I wasn't very clear about this, whenever we're doing this, we're setting y equal to 0. That's the rule for using the quadratic formula, because a quadratic formula gives you roots, which occur when y equals 0. Alright, so that is how you use the quadratic formula. And to make sure that you're watching this video, you should expect a quiz on knowing the formula for the quadratic formula. So you need to be able to write down in class on Thursday, x equals the quadratic formula, okay, that I gave you on an earlier slide. So you need to memorize that. Okay, so there's also one other way we can go. We can get to factored form, and that is from going from vertex form to factored form. So let's say I have an equation that looks like this. Okay, so if I want to go from vertex to factored form, the first thing I have to remember is that if I'm going to factored form, I'm finding roots, and when I find roots, that means that y has to equal 0. So I'm going to substitute 0 for y, and then I'm going to proceed to solve. So the first thing I'm going to do is I'm going to add 50 to both sides. So 50 equals 2 times the quantity, x minus 4 squared. Order of operations says that I do addition, subtraction, which we did, followed by division and or multiplication. This is the only thing left is the division. So now I have 25 equals x minus 4 quantity squared. Okay, the next thing is exponents. Well, 2 is an exponent, so now to get rid of the 2, I take the square root on both sides. Don't forget, when I'm the one drawing the square root bar, I get two answers, a positive and a negative, because I don't know if it's 5 times 5 that makes 25, or negative 5 times negative 5 that makes 25. Okay, and then on that right side I have x equals 4. So now I'm going to add 4 to both sides. So I have 4 plus or minus 5 equals x. So let's go ahead and look at this. So I have 4 plus 5 equals x. I also have 4 minus 5 equals x. So let's look at this one. So I have x equals 9. There's that one. And I also have x equals negative 1. So my roots are 9, 0, and negative 1, 0. Alright, I think you can hear my daughter in the background. She just dropped something down the stairs, so she's super excited. Alright, so I'm going to go ahead and write another practice problem for you. So I'm going to say 3 negative 3 times x plus 1 quantity squared plus 51. So to solve this, to write this in factored form, I'm going to go ahead and make y 0. And then I'm going to use order of operations backwards to go ahead and solve for my x values. So the first thing I'm going to do is I'm going to subtract 51. So I end up with negative 51 equals negative 3 divided by x plus 1 squared. Okay, the next thing I'm going to do is divide by negative 3 because we do multiplication and division next. And I get 17 equals x plus 1 squared. Okay, the next thing in the order of operations is to take the square root to get rid of the square. If I take it on this side, I take it on this side. And since I'm the one that drew the square root bar, I'm going to have to put a plus or minus. Now, the square root of 17 is not a whole number, and if it's not a whole number, we're not going to write it any other way. We're going to leave it as the square root of 17 equals x plus 1. Now, we're going to subtract 1 from both sides. So we have negative 1 plus or minus the square root of 17. And that is as simplified as we can get. So, that is how you go from vertex form to factored form. Alright, so one other thing that we're going to talk about really quickly is we can have no roots. And if we don't have any roots, our graph is going to look either like this or like this. It just doesn't touch the x-axis. So it'll be above or below but not on. We could have one root, and that means we have a double root. Okay, that means that our graph sits somewhere on the x-axis, and its root is also its vertex. So it could also look like this. So it hits the x-axis and goes back in the same direction it came. And then the most common one we're used to seeing are parabolas with two roots. And it could look like this, it could look like this, look a whole bunch of ways. So we can have graphs that have no roots, one root, or two roots. And that is all for this screencast.